Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Marvell with Sathya Subramanian. He's going to talk today about how to move more data back and forth wirelessly. So, Satya, what's the problem with moving more data? Typically, in the past, it's been one way with a lot of the download speeds and upload speeds have lagged behind it. What changes? What are some of the problems that we have to deal with?
Yes, great question. Actually, today there is a whole lot of new users, like high-end users. They are looking for a lot of bandwidth requirements, both uplink and downlink direction. So, for example, there are creators, gamers, collaborators. We call them as generation upload, and they do need a higher speed network with higher throughput, higher peak rate, and also we are looking at the multi-user MIMO OFDMA capability, and that's where 802.11ax fits right in, and it offers the both multi-user MIMO and OFDMA support, with which users, these high-end users, will be able to upload, download data pretty seamlessly.
And 802.11ax is the newest standard in wireless, right?
Correct. As you know, we have been in 802.11n, then there is 11ac, well actually 11ac Wave 2 as we speak today, and then there is an introduction of 11ax, and the standards are being still ratified, but we have been announcing products on 11ax in particular, because from a timeline point of view, the infrastructure will be ready in the next this year, next year, and then client devices on 802.11ax will follow in 2020 timeframe.
Why don't you draw this out for us?
Sure.
So what's driving a lot of this change here? Why do we need all these new standards? Is it IoT? Is it IIoT? Is it more sensors everywhere?
If you look at the thing which I mentioned earlier, which is the new generation of high-end users, the generation upload, the creators, gamers, and collaborators, they all look for like a lot of data throughput and the bandwidth. And the reason being is now we are going into this cloud environment, and there's a lot of VR, AR applications being run on the cloud, and we are relying on the cloud 24/7. So today's existing wireless networks, they don't scale for the requirements from these new applications. So as you know, we have been in 11n, and we are in 11ac Wave 2, and then we will be going into 11ax deployment, right? So in terms of infrastructure, we have been working in getting the 11ax chipsets ready, and that way the infrastructure will be ready by next year, and then 2020 timeframe is when the client devices will come in on the 11ax.
Any problems with using 11ax versus what was there before? Any change to the user or the infrastructure?
Yes, definitely you need to upgrade to the 11ax equipment, but obviously this is backward compatible. If there is a service operator requirement requiring backward compatibility, the standards allow you to be backward compatible. But again, it will be an equipment upgrade. In fact, that is the beauty of this 11ax, right? So you get the multi-user MIMO and OFDMA capability, both uplink and downlink. I think those technical advantages come in when you switch from 11ac to 11ax.
In the corporate world, you see this all the time because people working in a corporate environment see their internet access slow down fairly substantially over what they get perhaps at home. Basically, they're the only user on that line. Will this solve some of that problem?
Yes, definitely. Some of the segments that we are targeting actually is, apart from the enterprise access point, there's also retail access point, and there is a whole new segment which is the carrier gateways or in the home gateways, for example, and even set-top box, right? So once those devices have 11ax capability, you should be able to support these uplink, downlink more seamlessly with this. This standard actually going to be enabling those kind of a peak data throughput and the bandwidth.
Where does AX fit in with 5G?
Yeah, that's actually a great question. As you know, the 5G is actually on a multi-year rollout, so it's going to be a 3 or 4 year time frame. But we are actually seeing a lot of interest from in terms of last mile connectivity, in terms of the 5G rollout. For example, some of the fixed broadband service providers, we are working with them in terms of deploying the 11ax for them. So because 11ax actually helps them put together last mile connectivity, which will actually speed in some of the 5G rollout as we speak.
And so these two standards will coexist at the same time.
Yes, definitely. Yeah, 5G and Wi-Fi will coexist. Obviously, it is used for different applications. There are different use cases for both 5G and the Wi-Fi.
So what are we looking at here?
If you were to put together an enterprise access point, and what do you need to put everything together, right? So I'm actually showcasing a total solution here. The one in the middle is the CPU. You need a strong platform chipset to support all these Wi-Fi and other chipsets for this particular platform. And then you have the networking piece, for example, it's a 5-switch 2110, things like that from a networking gigabit Ethernet point of view. And then on the Wi-Fi side, you're actually seeing this is a tri-band radio solution here. So here I'm showcasing an access point based out of Armada CPU platform. These were the Marvell 11AX chipsets that we announced back in December 2017. So this is an 8x8 chip, this is a 4x4, and the 8x8 is actually a 5 gigahertz chip. And the 9064, which has an integrated Bluetooth PHY, and that can operate in dual band, which is the 5 and 2.4 gig. And there is an option to have a third radio here as well.
What is 8x8, 4x4? What's the advantage of one versus another?
Sure. The 8x8 actually means that you can actually transmit it's 8TX and 8 receive. And similarly, the 4 transmit and 4 receive for 4x4. Obviously, the 8x8, you can support, it'll have like 8 antennas. You should be able to support multiple devices. And a combination of that, as I mentioned earlier, with multi-user MIMO and VoIP DMA, you should be able to support up to 16 connected devices.
And so the goal here is to basically the same thing you're doing on a chip, put more into a device so you have fewer pieces of equipment floating around there, right?
That is correct. This is a lot of integration happening, right? So you're packing more capabilities. For example, we have integrated Bluetooth, we have Wi-Fi, and also the 9068, 9064. These are 11AX chipsets. It comes with several other advantages, such as it's got a precision location, and it's got Bluetooth integrated Bluetooth PHY, and we also offer the total solution, which is the enterprise grade, or actually a service provider software stack, and then so we are looking at total solution, right? So we provide not only the chipsets, but not only the Wi-Fi chipsets, but the Armada CPU platform, the networking PHYs, and then the total solution.
So in a real world setting, what does this look like? What changes in terms of how the data moves and what kind of data is moving around?
Right. So in a real world situation, will be the content of an enterprise access point, and if you open up a retail access point, you may not see like 3 radio. It'll be like a 2 radio solution. But then the idea is to, you need to have a stronger Ethernet connectivity, and then you need a stronger CPU performance. And that's where the platform chipsets come into picture. And then you also need high performance radio chipsets, and it happens to be the 9068, 9064 here, because these can operate in 11AX standards.
Is low power an issue on this as well, in addition to performance?
Yes, definitely. Any system level solution that you're working with, you need to have a minimum power requirement. But again, please remember that these are in an access point, meaning they are plugged in most of the time. So we do worry more about the dynamic power and not the standby power as you would see in a typical handheld or a smartphone device.
Is this just a standard ARM CPU that's going in here?
Actually, Marvell, we have a whole ecosystem of CPU platform chipsets. As you know, it's Armada chipsets, and we have a bunch of flavors. You can actually go for a single core or a dual core or a quad core. These are Armada is based on ARM industry standard ARM architecture, and we do we build these chips. And so, for example, in this kind of situation here, we have actually used a quad core, a Cortex A72. And as you know, Cortex A72 is the best high performance 64-bit ARM v8 architecture out there, and we have used that in this particular chipset.
And so when you integrate all these components, what do you get versus putting them together separately?
Yes, from a system architect or a system engineer point of view, I would prefer to go for a one-stop shopping and make sure that I have all these pieces, and I can I can focus on putting my solution together and then look into my value add from my offering point of view. So it is good that from a end consumer point of view, I mean from a system engineer point of view, I do want to have procure all these things from one place, and which happen to be this in this case here.
But all of this is geared towards moving more data more quickly and getting rid of bottlenecks wherever you can, right? That's really the core of this.
Exactly. So today we are able to have decent performance on the downlink, but then we are being bottlenecked on the uplink capability and multi-user MIMO and OFDMA and our total solution. In fact, you can see here in this solution, we have put a high performance networking switch, a high performance CPU, and a high performance radio to come up with a high performance solution, right? So we have taken out all the bottlenecks.
So when you think about wireless, this is a whole industry. It's not just one company, it's an ecosystem. What's changing on the ecosystem side, and how is that starting to play into this?
Yes, whenever you have this new technology and you want to take it to market, go-to-market is a very big metric that we all need to go after. And someone offering a total solution is great, but then they also need to work with a whole bunch of ecosystem players. In Marvell, we work with several ecosystem players, whether it's ODMs or OEMs, and also the system integrators. So we, apart from delivering the chipsets, the 802.11ax chipsets, we have gone several extra miles in working with some of the ecosystem providers, for example, the module vendors and system integrators, so they actually build these modules, and then the end customers would be able to take the reference designs and then design their own solution based on that. So all these things help an end customer to launch the product. It actually helps them from a go-to-market point of view.
Have those relationships changed over the past couple years? Or have they gotten much tighter than they were in the past because it's more complex?
Yeah, actually, we have been working with these ODMs for the past few years, but with 802.11ax, this is being one of the major milestone for the industry, and there is a lot of tight collaboration as we speak, and we are working with ODMs and OEMs and also system integrators to make sure we put the whole solution together, which makes it easier for the end customer.